Hello, I would like to present our paper, Design Factors Affecting the Social Use of Programmable Robots to Learn Computational Thinking in Kindergarten. And what is it about? It's about computational thinking, very young children at kindergarten level, and robots. Robots seems to be an useful tool to teach computational thinking to small children. And if we want to use them in school context, in real school context, we have to think about social aspects of the robots, because normally it's impossible that each child will have its own robot. So group work, it's the basic settings that, due to the cost, logical, and pedagogical reasons. So our aim in the study was to identify key design factors that affect the social use of the robots. So we worked with 15 preschoolers, 3 groups of 5 children between ages of 5 and 6, and with 3 different robots. So each group worked with a different robot with different input and output interface. We worked about 25 minutes doing the same activities, basic programming, like moving forward, backward, to the side, and then do more complex shapes like L shape. We registered the data with 2 digital cameras from above to see the children's distribution on the floor, and also from the side to see the face expressions. We did the content analysis with sticky notes and came out with some recommendations and results that I will present later on. So what is important in our research are the robots, because they're different. We work with Buckley that has a remote control. So to move the robot, you introduce the sequence of directions. You have buttons, so you can press the buttons and say forward, forward, to the right, forward, and then send the program to the robot. If it want to go to the side, it has to rotate and then go forward. And as the output, we have the robot's movements and also some lights and sounds. Robotita is a robot developed at my lab. It uses color patches that you can put on the floor. You should put on the floor, because it's sensed with the color sensor below the robot which color patch it is passing over, and then change the direction according to the color. It's omnidirectional, so it doesn't have to rotate to go to the side. It can just move to the side. And as the output, we have the robot's movements and lights. We have here a LED ring and LEDs that turn on and off. We have also Bluebot. It has integrated buttons, also arrows that you press if you want the robot to go to certain directions. You introduce the sequence of arrows and then press the green button to start to execute the program. If you want the Bluebot to go to the side, you have to rotate the robot and then go forward. And as the output, it has movement, lights, and sound. So we worked in group settings with each robot separately. So each group worked with 1 robot. And what we observed is the following. If we want children to discuss options and work in group while programming a robot, we have to ensure that all the group members can perceive the input. So if the input is not perceived, they cannot discuss, they cannot take decisions, they cannot exchange opinions. So what we identified as a good idea is to use tangibles, because they can be laid on in the center of the group, so everybody can see them. And for example, sound and tactile clues should be also included to ensure that the children with low vision or blind children can also perceive the input that is sent to the robot. We noticed that the input controls on the robot cause problems because everybody wants to touch them, and children are touching very fast. The small buttons, for example, like in the case of Bluebot on the picture, and they have to come very close to the robot to do this. So some group members, as we can see here, the boy that is separated from the group cannot see the input and cannot provide helpful feedback. So we propose that if the robots like Bluebot, due to the cost or other reasons, should be used in the classroom, facilitators should provide instances of discussion of the program before entering the comments, so everybody can see or hear and or perceive the comment before they will be entered to the robot. The perception of output seems to be also a relevant issue, because if the robot does something that we don't want it to do, we have to perceive this. So we had problems with Bluebot because the buttons that it has on the back invited the children to press them all the time while the robot was moving and executing a program. So there were hands on the robot, there were hands around the robot, because the child that programmed the robot wanted to protect the robot from the other children. So the output, because of this hands on and around the robot, the other group members cannot perceive easily the actions of the robot. So it's also a little bit related with the size. The bigger robots, it's easier to perceive, and the necessity of the multimodal inclusive feedback that will help all the group members perceive the actions of the robot. On the other hand, the perception of program state was relevant because it helps to correct the program if you know which step is this one that was the wrong one. So to have the visibility of the program during the execution help to ensure that you see what will come next, what actions were executed before, and can identify better and discuss how the program should be correct. And the visibility of the instruction and execution, it's also relevant. If we see that what is in execution, we can identify better which step is the false one. And execution speed also helps to gives you time to think about what will come next, what happened that the program didn't work. And it seems to be a good idea and able to control when the next instruction will be executed. So to go step by step, like in the case of debugging software, that you can move in the program when you want. If these features are not provided by the robots, facilitators could help and introduce the commands one instruction at a time. For example, we have 4 steps. The facilitator can introduce the first one, execute, ensure that it's correct, execute first and second. If it's correct, then proceed until you execute the whole program. We noticed that positional perspective at this age can be an issue because of the spatial skills that the children are developing. So if the perspective of the robot is different from the perspective of the child, we can have some problems. So if the mental rotation is not the goal of the activities, perhaps we can choose the robots that do not have to rotate to go to the side, like in the case of Robotito. We observed that sensory distractors can be a problem in group settings because the additional elements invite children to play, to distract, and not pay attention to the activities. And we also observed that individual initiative can be beneficial for group learning, because the exploration of the children that are more self-secure and more curious help the shy children to learn new things. So the designs should invite children to to exploration because it's beneficial for the group. Well, that was everything, our results and recommendation. Thank you very much for your attention.